Okay. Good morning, everyone.
Good morning.
Thank you. How's did the homework go? Do you have any questions? Please put them on chat. I would like to finalize linear function today and then start the chapter 2. So any questions you guys had difficulties with?
About the quiz or the practice problems?
No, it doesn't matter. Whatever you have difficulties with. The quiz, you mean the Moodle, the online homework?
No, I meant like the quiz from Tuesday.
I haven't graded it yet.
Oh, okay.
Yeah. Usually I like to discuss it after I grade it, so I know exactly what you guys have done. So I honestly didn't do it. I mean, I didn't have time, period. So Tuesday, I will definitely go over all your mistakes, okay?
But speaking of the Moodle,
Yes.
One of the questions acts really weird when it says it wants polynomials on both sides. So it doesn't want you to like it'll be like 3y equals something. It doesn't want you to take the 3 away from the y for some reason.
Yeah, the one of the issue that students are facing in this problem is the way they are writing. Let me see if I suppose you got 3y equal x plus 3, for example, right? X plus 4. I don't know what you got. I mean, because each student get a different problem. Okay, so, and the way we've done it in class, to be able to identify the slope, we divided by 3, correct?
Yeah.
Okay, so, okay, x over 3 plus 4 over 3. We divide across by 3. Now, here's what's happening. When you guys are writing x over 3, you're writing, I know you know what you're doing, but the writing is problematic. You should write 1 over 3x plus 4 over 3, correct?
Yes.
Now, you're writing like this. The way Moodle is understanding what you're writing is that.
Oh, then
That's
how
what
are we supposed to
put parentheses.
Oh, okay.
Moodle understanding this. So Moodle telling you this is not a polynomial. What they mean is that x is not to the power 1, x is the denominator. So Moodle is having difficulty with this, with that, because that's what they are understanding. So if you put it like this, 1 over 3 parentheses times x plus whatever, then no issue. Okay?
Yes.
Yeah, and I know that this is a lot. Another student wrote to me and told me, probably it's the same. I don't know. Told me about this, and that's really the situation. I think Moodle is accepting this answer, but if you try to do it because you want to recognize the slope and you want to write it this way, that's the way they want it. They want 1/3 in parentheses. Otherwise, they are reading it. And it's a program. Those are not. I mean, they are intelligent at the same time. What you give them, that's what they understand. It's not they don't understand what's in your mind. So they're understanding this one. Okay, so that's the issue.
One of the questions also accepted decimals too.
Is it or is not?
One of them, I don't remember which one, but one of them let me do a decimal for the answer, like y equals 0.66x plus.
That's fine. That's okay. Yeah, no issue. I didn't know whether they accepted or not. Any other problems? Okay. So as I said, I want to finish this section today. It was my own peace of mind. So there are. Let me make sure all of you can give me the equation of this line. Suppose I have a line like this. So I'm going to put -1 just to make sure we're all on the same. And 2. Okay. Quick question: what's the equation of the line here, and what's the equation of this line? Those are the special lines. I talked about them last time. Okay, give me the equation of each one of them. The first one.
Yes. Is 0.
What? That's
First
the line.
one.
This, the dashed line.
Or the slope. No, that you said you're asking for the equation. I'm just saying the slope.
Yeah, the slope is 0. Correct. What's the equation?
1 second.
Everyone, I want everybody to be able to answer this question. Because we have to. We should be able to. So if the slope is 0, what's the equation of this horizontal line? No, yeah, okay, never mind, okay.
Y equals 0, x minus 1.
Yeah, which give you what? Would turn into what?
Y equals -1.
-1. That's the equation. Because that's what characterizes every point on this line. So the way you can think about it, what characterizes every point on this line? Every point on this line, its y coordinate is -1, regardless what the x is. So that's what characterizes all the point on this line. That's the equation of this line. Okay, what's the equation of line 2? What's the slope here?
Wouldn't it be undefined?
Absolutely. The slope is undefined because there is no change in x. X is constant here. X is always 2. So here the slope is absolutely undefined. But what's the equation of the line? Still, we have an equation. It means still we have a way to describe this line using an algebraic equation.
X equals 2.
X equal to. Okay? Every point on this line, its x coordinate is 2. Regardless what y is, the x coordinate is 2. So that's how we say that's the line x equal to 2. Okay, so it's not the point 2, that's the line x equal to 2 represent this vertical line, y equal -1, this horizontal line. So absolutely important line that we have to know. Slope 0 and the slope undefined. Okay. The problem that I would like to discuss with you before I move on from this section is the following. Okay, I would like to do one more problem that deals with perpendicular to make sure you guys can handle that, and one problem that deals with intersection to make sure you can handle those type of problems. So I will pick one that I hope you guys have the answer because I expect you to have done those problems. So number 19, for example, find equation of the line. So the line passes through the following point. So they're giving us a point 10, 12, and it's perpendicular. So that's information about the slope to the line 3y plus 2x minus 12 equal to 0. Okay, so they're giving us the point, and they're giving us not the slope. Did anyone else audio cut out? Can you guys all hear me?
Yes, I can hear you.
Okay. All right, so it's passed through this point and perpendicular to this line. All right, so we need to find the equation. I have a point, I need the slope. So to find the slope of it, first we need to find the slope of this line. Okay, first we need to find the slope of this line. All right, what's the slope? We're gonna rewrite in the format mx plus b. That's how we can pull up the slope. So I will get dy equal
-2 plus 12.
minus x plus 12. And what is the y? Please work with me quickly.
Negative 2/3 x plus 4.
Plus what?
4.
4. We divide across by 3. Across by 3. Okay, so be very careful. So the slope is whatever x is multiplied by. X is multiplied by minus 2/3. Okay, so that's the slope of this line. That's not the line that I'm interested in. That's the line I'm interested in. So now let us go back to this line. The point is tan 12, and the slope is -1 over -2/3. Okay, so this is gonna give me how much? I leave it to you. -1 divided by -2/3 because they are perpendicular. Okay, so this is perpendicular to this line. It means the slope is -1 to that. And this is gonna give me how much if we use the property of fraction? Okay, now let me pick one of you. Let me pick one. Okay. Madison, are you with me? Madison?
Yeah, I'm with you.
Okay.
Sorry.
That's okay.
My dog keeps barking.
Shut him out. Tell him go to another room. You're working. Okay. What shall we have for slope? How would you divide those? Are you with me or you lost me? Ah, sorry. Yeah. Not 3. Why 3? Let's do it. It's -1. That's the numerator. You multiply it by the reciprocal of the denominator. The denominator is 2/3. So you multiply it by -3/2, which is going to give you 3/2. Okay? So it's not a third here, -1 over -2/3, which is going to give me 3/2. Very good. So the equation would become a point, a slope. We have equation. Y minus equal. The slope is 3/2. The point is 12 for the y, x for the 10. So that's the point. That's the y0, x0. That's the slope, x minus x0. And that's the formula I'm using for the point slope. And now the rest is easy. I just do the algebra. 3/2 times x is 3/2 times x minus 3/2 times 10 is going to give me 30 over 2, which is going to give me a 15. And then my y is, I added 12 both sides, will give me -15 plus 12, which is going to give me -3. Okay, so that's just a review for those perpendicular. If the lines are parallel, they have the same slope, so it's much easier. Perpendicular, we have to do a little bit of work. And do one more problem, and then I think we are ready to move on, unless you guys have any questions. I'm going to look at number 40. Okay. It's not hard, but we have to be able to do it. So number 40. The population of a particular town in the state of New York was 9,000 people in the year 2000 and is shrinking at the rate of 200 people a year. The population of a particular town in the state of Maryland was 5,000 and is growing at the rate of 100 a year. The question is, when will the population of the town in Maryland be greater than the population of the town in New Jersey? So how shall we do this problem? So we're comparing two populations in two different cities. And the question is, I'll give you 2 minutes to interact with it, and then we discuss it. right? Anybody has any idea? Any ideas? How can we handle this problem? Let's read it, and we read in it, you guys will pitch in, okay? Because we should be able to do those type of problems. So let's read them. We have two towns. So we have the town in New York, and in 2000, it has 9,000 people, but it's shrinking at the rate of 200 a year. Another town in Maryland was 5,000 and is growing at the rate of 100. So one started much more, but going down. One started less, that's going up. So at sometimes the ones that started less but going up is going to catch up with the other one. And the question is, when will the population of the town in Maryland be greater than the population of the town in New Jersey? So how can we set up this problem? Okay, so I'm starting to have an idea. We're going to introduce two functions. So your classmate introduced one. So I'm going to call f of t the population in, according to your classmate, that's the population in New Jersey, the town in New Jersey. The population town in New Jersey, t years after 2000. 2000, okay? And g of t, another one, is the population in the town in Maryland, t years, because we have two different things after 2000. All right? So we have two populations, so we have really two functions. All right. Who can give me the formula of f of t? What's the population after t years? The population is, as we always did, initially 9,000. And it's shrinking at the rate of 200 per year. Means after 1 year, it's going to do down by -2. So what's going to f of t? So since math told us, it's going to be initial minus 200 t. Make perfect sense. Or if you like to write it in the form mt plus b, it's minus 200 t plus 9,000. What's a constant rate? 200 every year. So this is f. Now what is g of t? Quickly, what's the formula for g of t? And I'm going to pick one of you this time because I know Matt wrote it for us. Very good. So we're going to see how g is working. That's g of t. That's another function. It started by 5,000. It's increasing by 100 at a constant rate. So 100 is my slope. So it's 100t plus 5,000. So this is the formula. Okay, so the question is, when the population in Maryland will be more, at what time we will have more people in Maryland than we will have in New Jersey? So how can we solve this problem? I'm going to sketch graphs because I understand a little bit graphically what's happening. Let's see what the graph is. Let's start with New Jersey. New Jersey started by 9,000 up here. That's what it started. But it's decreasing. Every year, it decreases by 200. So that's New Jersey. And that's f of t. The other one started below 5,000. It's increasing at the rate of 100 per year. This is g of t. G of t is the town in Maryland And this is the town in New Jersey. Okay, so this is really the problem. What I would like to do. So this is New Jersey. Probably I should put New Jersey in a different color, so to contrast them. So the black is Maryland and the red is New Jersey. And the question is, if you watch the picture at the beginning, we have more in Maryland than New Jersey. They start at 9,000. They are decreasing. So we still had more at some point. And then there is a certain time, because one is decreasing, one is increasing, the Maryland is gonna take over. Sorry, the New Jersey is gonna take over. So right here, no, Maryland is gonna take over. So the question is, when does this happen? How can we figure out this answer? What do you want me to do? Ideas? How can I find this T? Matt, what do you think I should do? Since you gave me all the formula, what do you think I should do?
Set one greater than the other.
We can do that. So what do you want me to do?
So you could do f of t, yeah, or you could set them equal, right?
Right. We can find the time when they are equal. And after that, we know what's going to happen. So we're going to find the time when the population, f of t is the population in New Jersey equal to the population in Maryland. So basically, we're going to find the intersection. Exactly. We're going to find the intersection of the two lines. Once I find the intersection, and then I am set. Okay, so that's really the idea. That's the idea of intersection that we did last time. So f of t is minus 200t plus 9,000. And this is 100t plus 5,000. So when I say, okay, when they will catch up with each other. And now we solve for t. So to solve for t, I have to put the t's together, minus 200. So I'm going to add 200 from both sides. I take 5,000 from both. I subtract 5,000, which is going to give me 4,000. And then I divide by 300. And this will give me t equal. We can evaluate this. This time I will accept a decimal in here. And it's going to be 40 over 3. So this is going to give me a little bit 12 point something. Okay, so 13.3 years. Okay, so it means right here that 13.3 years. So the population in Maryland will become greater than the population in New Jersey after 13.3 years. End of the problem. Okay, so that's the idea of the intersection that we talked about last time, but that's a problem that tells you, when do we need to work with that? Okay. Right. Please do the practice problem. It's crucial because that's how you're going to understand. So the practice, between practice and model, you guys will be all right, but you have to do the work. All right. So today we're going to move to chapter 2 and back to functions. So what we saw so far, the idea of a function, which is a rule that assigned to a certain input value and output value. We learned a little bit how to work with them. And then we studied linear function. And linear function are those functions where the output changed by the same amount every unit of input. We learned how to find the equation for them, the formula for them, how to interpret the two. Now we're going to go back to studying functions, okay, in general, some properties of function. So section 2.1. the notion of a domain. Domain of a function. Okay. And before I start the domain, I'm going to do a tiny bit of an algebra background, not much, and then I'll start the domain. So algebra background that I need for this section. Okay. All right. And it's an easy one. Suppose I ask you to solve the following inequation. So solve the following inequality. Okay. Very basic stuff. Suppose I tell you to solve x plus 4 positive. Simple. What do I mean by that? It means I want you to give me all the values of x that makes this expression positive. So solve this inequality. It means give me all the values of x that makes x plus 4 positive. So for example, x equal 5 will do it. X equal 0 will do it. If x equal minus 1 will do it. So let us recall how to solve these inequalities. Okay, to solve inequalities like this, it's like solving the equation. I try to isolate my x, keeping track with the sign. So I say, okay, if x plus 4 is positive, I subtract 4 from both sides. It means I need x to be larger than minus 4. Okay, I know you've seen this stuff. I'm not really oblivious to that. It means every x bigger than minus 4. So the solution will be all values of x. So that's the solution. All values of x that has the properties that x is larger than minus 4. So you give me anything bigger than minus 4, for example, minus 3.9, plug it in here, add 4 to it, I get a positive number. Okay, let's do another one a little bit along the same line, nothing really hard. Suppose I want to solve 2x minus 3 less or equal to 0. So the only thing here I did is I put equality. It means I'm allowing 0 to be part of it. So again, I need to isolate my x. It means for this to be happen, it means 2x has to be less than 3. And I divide by 2. And this will give me x is less than 3/2. So the solution is every number less than 3/2. All value of x that has the property that they are less or equal to 3/2. So 0 will do. No, will 0 do? Yeah, 0 is less than 3/2. 0 minus 3 is negative. 1 will do because 2 times 1 minus 3 is negative. 1.4 will do because 2 times 1.4 is 2.8 minus 3 is negative. Anything less than 3/2. All right, let's do one simple one. One more. 3 minus 4x positive. Okay, I give you 1 minute to give me the answer. Which axis will make this expression positive? Okay. Whoever's ready, put their answers on chat. Okay, all values of x such that x less than 3/4. The answer is correct, so let us do it. I'm gonna do it. Okay, suppose I'm gonna solve. I'm gonna solve it like this, not the smartest way to do it, but because I wanna make a point. So I'm gonna isolate in x. Just give me, so I take away 3 from both sides. Okay, and now I need to isolate my x. To isolate my x, I have to divide by -4. Okay, and now here's the thing about inequality. Here's the thing. If you have an inequality, when you multiply or divide both sides of an inequality by a negative number, then what should we do? What will happen? So if you have -4x, I want to divide by -4. When you divide both sides by a negative number, you have to change the sign of your inequality. And that's very important. It's less than -3/4 over that. Okay, so when you multiply or divide by a negative number, you change the sign of the inequality, or you change the inequality. And this will give me x less than 3/4. And I will say a little bit about it, why. So 3 minus 4x, if you do -4x less than -3, because I need to divide by a negative number, the inequality have to change. The bigger will have to become less, and then we'll get x less than 3/4. So the solution would be all values of x, such that x less than 3/4. Okay, and that's the comment I would like to make, or to remind you that whenever we multiply, divide by negative, we change. And let us see intuitively why this is true. Suppose I tell you 2 is less than 3. Big deal. Okay, if I multiply both sides, so on the number line, this is 2 and this is 3. If I multiply both sides by -1, for example, this will become -2. And this will become -3. -2 is definitely not less than -3. -2 is absolutely bigger than -3. Okay, so whenever we multiply or add by a negative, we have to be careful. So now this is a little bit of algebra background because we needed to talk about the domain. So what is the domain of a function? So domain of a function. Not the favorite section for the student, but we have to talk about it because it's crucial. So the function is a rule. You know, you give it a bunch of input, bunch of values, which change. Those values change, and give for every input a certain number that we call the output. That's really a function. What is the domain? The domain is basically all the input values, all those input values. It means the thing you assign something to. That's really what the domain is. So suppose I take the following function. Rule, before I define the domain much better than that. So suppose it takes 0, 1, 2, 3. And take this to -5, takes this to 3, to 6, and to 9. So that's my function. So if I tell you what's f of 0, you tell me, okay, according to your rule, it's -5. What's f of 1? It's 3. What's f of 2 is 6. What's f of 3 is 9. What's f of 4? You look me up and tell me you didn't tell us what it is. So the domain here, the domain is all those input for which you can find an output. So the domain is going to be 0, 1, 2, and 3. So in this particular problem, the domain is going to be 0, 1, 2, 3. Now, let us define the domain. So definition. Okay, suppose f is a function. Means it's a rule. A function. The domain of f R. The domain of f is all the x values, if you want, all the x values, such that f of x exists or makes sense. So we have an f of x. Okay, so the domain are all the x values such that f of x exists, or we can say all the input values for which there is an output, all the input values that yield an output. And now we're going to work with it. So if you have a function, it takes a bunch of numbers and assign to each one of them something. The domain are all those x values such that f of x exists. It means there is an output that corresponds to them. So in this first example, it's a very simple. My domain are 0, 1, 2, 3 because I only have output for those values. Example number 2. Suppose I graph a function. Tell you, okay, this is a function, and this is the graph. That's the graph of this function. So I'm going to be very precise. This is the graph. I'm going to cut it here and here. That's the graph of the function. Means if I have an input here, remember the input are all on the horizontal, the output is this vertical distance from here to here. What's the domain in this particular situation? The domain are all the input values or the x value for which f of x exists. So what's the domain here? In other words, if I tell you what's f of 5, what's f of 6, what would be your answer? Is there an output for 6?
Undefined.
Undefined. What is f of 7?
We don't know.
What's the domain?
The domain is everything from -1 to 5.
That's everything from -1 to 5. So that's really the domain. All those input for which we have an output. So the domain are all values of x, such that x between -1 included and 5. That's the domain, everything that has an input. So if your function is given in a graph, finding the domain is easy. You just really look at the graph and say, okay, for which x value she's giving me an f of x. The problem is when the function is given by a formula. It means it's not easy like this, a table. It's not easy like here. It's really a formula. So, and what do we mean by the domain there? So we take a formula and we analyze the domain. So domain of functions given by a formula. Suppose I take the following function. So how to determine domain? How to determine the domain when f is given by a formula, which becomes a bit more abstract. Okay. So let me take a formula. Suppose I tell you that f of x equal, very simple one, x squared plus 2. What do I mean by the domain in this case? That's just a formula. It means all the value that you can put here, such that when you evaluate f at this, you get a number. So what are the values that you can put here so that when you evaluate f at it, you still get a number? Is there any value of x that you're going to have difficulties inputting? So for example, if I put 1 in here, are we going to have an output as a number? Yes or no? Quickly. If I put f of 1, what I'm going to get? 1 plus 2. If I put 3, what will I get? 3 squared plus 2. So can I put any number I want for x? And f of x will still make sense? Yes or no?
Yeah.
Yeah. So the domain here is going to be all real number. Because I can put anything for x. And f of x will be a number. I don't have an issue with that. Okay, now suppose I take f of x to be 1 over, I'm going to introduce a denominator now, 1 over x plus 4. Okay. And now here's my question, the same. The input, the domain R, when a function given by the formula, all the values that I can put here so that f of this value is an actual number. So suppose I have the function 1 over x plus 4. Is there a value that you think will give me a problem when I input it here? So as I said, this become a little bit more abstract, but it's not hard.
When you're saying like a real number, do you mean just like a whole number, like no fraction?
No. No, real number, it means anything.
Okay, okay.
Absolutely, absolutely. Real number is 1/2, is 1/3, it's square root of 2. Everything is a real number. So can I input anything here and still I get a number? Okay. Would you like me on number 2? Not really. There is an issue here. And that's why we're studying that. Which number do you think is going to give us a problem before I give you what's really going on? Remember, we have denominator. Whenever you have denominator, something should come up to our mind.
0, if you put 0 in, it won't work.
If I put 0, does it work? Okay. Is 0 in the domain? Okay, I am going to put f of 0. Does it yield a real number? Does it need? It's 1 over 0 plus 4. It's 1 over 4.
Oh, oops.
No problem with it.
You have zeros in the denominator.
Okay, so now we're making more sense. So what you're telling me that anything, go ahead.
-4.
-4. Anything that's going to make this denominator 0 is going to give me a problem. Any value of x that will cause this denominator 0 will give me a problem. And in this particular problem, you guys are figuring it out. It's -4 in the domain. Okay, that's really what's, okay, f of -4 is 1 over -4 plus 4, 1 over 0 doesn't make sense. That's not a real number. So -4 is the one who's going to give me a problem. That's the only one. So now how are we going to do it? We're guessing it because we have to understand the picture, but now how are we going to do it? So the way we're going to do that is basically we're going to find the values that makes the denominator 0 and exclude them, get rid of them. Everything else will be in the domain. So f of x, I will write this a little bit wordy for the first time. F of x will yield an output, or will yield a number if you want, an output for all values of x such that except those, for all values except those where x plus 4 is 0. Where x plus 4 is equal to 0. That's right. So the f of x will yield an output for all values of x except those where x plus 4 equal to 0. So now to find the domain in this problem, okay, we figured out, we find, basically we solve x plus 4 equal to 0. And that's going to give me x equal -4. So to find the domain, we basically ask ourselves, which values of x makes this 0? And so to find the domain, we solve x plus 4 equal to 0, give me x equal minus 4. So the domain now is everything except those. So the domain is all values of x, such that x is different than minus 4. And that would be my domain. So whenever a function is given by a rule, by a formula, and there is a denominator in the formula, then what we should do is basically start asking ourselves, what x's makes the denominator 0? So we set the denominator equal to 0. This values of x has to be removed. Now, how will this affect the graph of the function? It means if I sit down and start graphing, let's see what does it mean, graph. So suppose I take the function f of x equal 1 over x plus 4. Okay, and I graph it. Basically, I take x, I take 1 over x plus 4. And I start picking values and I evaluate. So for example, I pick minus 2, minus 3. Now if I pick minus 4, nothing happened. I pick minus 3, I have a number. It's minus 3 plus 4. It's 1 over 1. Minus 2, I will have 1 minus 2 plus 4 is a half. At 0, I will have 1 over 4. And at minus 5, I will have 1 over minus 5 plus 4, which is minus 1. So if I actually, what's going to happen in the graph? What's going to happen is the following. When x equal minus 4, there will be no output. It means when you graph it, for minus 4, the graph will not hit this line. You will never see that because there is no output at minus 4. And if I start plotting this point, so you're going to have a graph that looks something like that. 2 pieces. That's how the graph would look like. It will be totally 2 pieces because at minus 4, there is no output. So the graph will never hit minus 4. So you're going to have 2 pieces. And that's really the effect on the graph. Okay. All right. So let's do other problems along the same lines. And suppose I take f of x equal. Again, the question is the domain, another simple one. 1 over 2x plus 6. And the question is, find the domain. It means all the x's, all the input, such that f of x will yield a number. Okay, you guys have a minute to do that. And then I'm going to pick one of you to see what you got, what you guys got. Anybody ready? Before I pick.
All values of x such not that it would be, what do you refer to the equal sign with the line crossed through it?
Different.
X different to -3.
Yeah, different or not equal. It doesn't really matter. That's what it means. Okay, how did you get that? Did you guess or you solved?
I kind of just looked at it like the last problem. I was like, oh, if it's -3, it would equal 0 on the bottom.
Okay, that's fine, but I want you also to be able to solve, because if the expression is a bit harder than that, you won't be able to see it, all right? So which value we have to exclude? We have to exclude all the values of x that makes the denominator 0. To 0. That's really what we have to exclude. All values of x that makes the denominator 0. And now we solved for the denominator. So we say, okay, what makes them 0? 2x plus 6 equal to 0. We solve. It means 2x equal minus 6. It means x equal minus 3. Okay, so all those, this value has to go because this value makes the denominator 0. So the domain is all values of x such that x is different from minus 3. Okay. Now the reason I make you solve because I can give you the following problem, which is I will before I move on to another one. Okay. So again here, when we graph the function, when we graph it at minus 3, there will be no output, absolutely no output. There is nothing here. So the graph is going to be two pieces, before minus 3 and after minus 3, because there is no output at minus 3. All right, let me give you one more along those lines before we move to another type of problems that deal with this idea of a domain. So whenever I have a denominator, something should always click. I have to remove the x's that makes the denominator 0. So I'm going to give you two more. This one and this one. Okay. C, find the domain, and then D, find the domain. Okay. Let's see. Jake, are you with me? Jake?
Yeah, I'm with you.
All right. What did you figure out? What did you figure out?
I was honestly having a little trouble with that one. I couldn't.
Yeah, I don't, yeah, because you cannot guess it. So what's going to give us a problem? That's why we're trying to develop a strategy to do it. What give me a problem? Which value of x will give me the problem? Everything that makes the denominator 0. Right. So the way we're going to do it is we're going to find all value of x. So the domain are everything except, so we're going to basically find the values of x that makes the denominator 0. And those are the one I need to get rid of. Jake, are you with me?
Yeah, I am.
Okay. So what x will make this denominator 0? If for x minus 3 equal to 0, it means what should be x? Solve. Just solve.
Yep.
That's why I wanted to see it also as solving. So x would be what? For x equal 3, I divide by 4 both sides. X equals 3 over 4. So the domain is, if I take x equal 4 over 3 over 4, and plug it here, I will have 1 over 0. So the domain is going to be, I have to exclude everything that makes the denominator 0. So all values of x that has the properties that this x is not 3 over 4. It's not 3 over 4. But 3 over 4 will make my denominator 0. I have to exclude them. There is no output for that. Does it make a little bit more sense? Jake, are you with me?
Yeah, it does make more sense.
Yeah, so that's why, so whenever you have the denominator, you say, okay, what makes this denominator 0? Which input? That's what makes it 0. I cannot have that in the domain because I will have, if I plug in 3/4 here, I'll get 1/0, which is nonsense. Now D, again, so we'll be done with denominator, and then I move on to something slightly different. Okay, what's the domain here? Absolutely. Anybody else? Ask yourself the same question. Is there a value of x that makes the denominator 0? And those, you get rid of them. Okay, let me pick somebody. Isabel, are you with me? Isabel.
Yes.
Okay, do you have any feeling for what this could be?
Wouldn't
Ask
you
yourself. What?
multiply 1 by x squared plus 4?
What can make this expression? So the question would be, what make denominator 0? So I'm going to ask myself. So I'm going to set the denominator to be 0 and ask myself, what makes the denominator 0? So,
You would subtract 4 from both sides.
okay, we're going to subtract 4 from both sides. And then?
And then you get -4. And then would you square the -4, square root the -4?
No, that's the issue. Does the square root of -4 make sense?
No, because you can't square root a negative number.
Right. So, can you find an x such that x squared equal -4?
-2.
And what's -2 squared? It's -2 times -2.
Negative or +4.
Right. So no matter what number you input, this cannot occur. So x squared -4 equal to 0, give you x squared equal -4, but this can't occur. Because x squared is always what? What do you think I'm going to write?
Always 0.
No,
Positive.
positive. Because any number you square, you get a positive number. So if we try, so suppose we set x squared plus 4 equal to 0, means x squared equal -4. It means this can never occur because x squared is always positive. So what does this tells me about the domain? Is there any value of x that makes the denominator 0? Nothing. No matter what you input here, no matter what you input 0 for x, you get 4. You input -1 for x, you're squaring the -1. It's going to become +1. You're adding 4 to it. That's not going to be 0. So the domain here is going to be nothing makes the denominator 0. So it means x squared plus 4 is always different from 0. So the denominator is never 0. So the domain is going to be all real numbers. Okay. So the process is the same. Whenever we have a denominator, we ask ourselves which axis makes it 0. We exclude those axes. And that's the domain. In this particular scenario, nothing makes the domain 0. No matter what you input here, you will never have a 0 down here because that's 4. You're adding to it a positive number. There is no way on earth you can make this into a 0. So you can input any number you want. F of x will yield a number, an output. Now, another part of the domain, another type of functions where the domain his issue is the following. And this whole section is about two types of functions given by a formula. So whenever I have the denominator, I have to be careful. I have to exclude those who have 0 in the denominator. Another scenario that may occur is the following. Let's talk about the square root. Let's talk about the square root a little bit. When you find the square root of a number, like square root of 4, what's the square root? It's a number, so that when you square it, you get 4. Okay, square root. So, square root of a negative number should be something such that when you square it, you get a negative number. Okay, but this cannot happen because any number, when you square it, you have to be positive, but this cannot occur. So the square root of a negative number is not defined. Okay, so square root of -4 doesn't make sense. Square root of -5 doesn't make sense. None of those is defined. So whenever I have a square root, for the square root of something to yield an output, what's under the square root has to be positive. So why we are talking about that? So now another example. Find the domain of the following function. F of x equal the square root of x minus 4. Okay, what's the domain? It means what axis can I put in here so that when I plug it inside the formula will yield an output. That's really the domain. And before we do that, let me ask you a question. Is 5 in the domain? Is 5.1 in the domain? Before we even find it algebraically, is 4 in the domain? Okay, question number 1. Is 5 in the domain? Means if you plug in 5 for x, you get a number. Yes, because this is 5 minus 4, that's the square root of 1, which is 1. That's a number. Is 5.1 in the domain? Okay, now I'm going to ask, Jillian, is it in the domain? Jillian Shaw, are you with me? Okay, I don't, if the student is not with me, the student is not with me. Matt, yeah, Matt, you're with me. Matt Trimmer. Is 5.1 in the domain? Matt, are you with me?
No.
No, because plug in 5.1 for x. Does it yield an output? What do we get? 5.1 minus 4. Correct? It's equal to what? What's 5.1 minus 4? 5.1, what?
1.1.
1.1. Is there any issue with the square root of 1.1? Is this a number? I mean, is there something that when you square it, you get 1.1? I mean, if you pick up your calculator will do it. So if you pick up your calculator, basically, and you evaluate 1.1.
1.04.
Yeah, which means that when you square this number, you get, honest to goodness, 1.1. That's really what it means. That's what the square root is. You take this number to the power 2, you get 1.1. So is 5.1 the domain? Back to you now. It means is f of 5.1 a number? It doesn't have to be a whole number, just a number. The answer is yes. Is 4 in the domain? It means if you plug in 4 for input, is the output a number? That's really what we are looking for.
It would be no, because you can't do square root of 0.
Okay, let's see, let's discuss this. Why we cannot do square root of 0? Can you think of something when you square it, you get a 0? Can you think of a number? When you square it, you get a 0.
Does that count?
Yeah, that's
Oh,
what that's the definition.
I
What's
guess,
the what?
then I guess 4 would be in the domain of just that.
Right, because the square root of 0 is 0. 0 squared is 0.
I thought that would be like a 0 divided by 0 sort of thing.
There is no division. Why there is division? Does f of x involve division?
No, that's not what I meant by like, I thought it would be like similar to like 0 divided by 0 isn't a thing you can do. So I thought like 0 squared.
No, that's a totally different algebraic operation. You're looking for a number. When you square it, you get 0. The number is 0. No problem, ask. Are you with me? All of you.
Yes.
Who can give me something not in the domain? Okay, anybody else? So I'm gonna pick your what?
3.
3 in the domain. Okay, we evaluate f of 3. That's really what we are doing. Now, of course, this is tedious. We're gonna do it in a very shorter way, but you have to understand what I'm doing. It means if I plug in 3 for x, will this yield a number? That's the square root of -1. Now, is there a number when you square it, you get -1? That's what the square root is. Is there a number? What's the square root -1? The definition is it's a number. When you take it to the power 2, you get -1. Now, no number. When you square it, you get -1 because every number, when you take it to the power 2, whether it's negative or positive, it gives you a positive number. So if you take -1 times -1, you get +1, which is positive. 1 times 1, you get 1, which is positive. No matter what number you input, when you take to the power 2, the number has to be positive. So square root of -1 is definitely not defined, not a real number. So 3 is not in the domain. So no, absolutely not. Okay, who can give me another one in the domain? Not in the domain.
Anything lower than 3, so 2, 1, 0, and so on.
You're not 100% correct. You're 50%. So my question is, I would keep along the same line till we figure it out. And then, so I'm going to put this here. Is 3.9 in the domain? I give you a minute to figure that out. Is equal to what? 3.9 minus 4, which is how much? 3.9 minus 4. Is this a positive number or a negative number?
Negative.
Negative, because 3.9 is less than 4. So this is minus 0.1. So not defined, not a real number. So the answer is, again, no. So now let us see what is going to be the domain. What's the domain of this function? It means which axis I can put in here so that f of x is a number. And the axis that I can put in here will be all the axes that will make this term under the square root to be a positive number. So the x's that I can put are all the x's that make this expression x minus 4 positive. Those x's will be allowed. Those that make it negative will not be allowed. So everything here, has to go away because it makes this expression under the square root negative. That's not a number. 3 minus 4 didn't work because it makes the expression under the square root to be negative. So what will work is what makes the expression under the square root positive. So now, how do we solve this problem? So this was a preparation to the way we're going to solve it. So f of x equals square root. Okay, we need to find for the domain all values of x that basically makes the term under the square root positive or equal to 0. Okay, so this is the domain. All value of x that makes the term under the square root to be positive. Those are the x's which will be allowable. Those are the x's that will give me an output. So now we have to solve x minus 4 positive because that's what I want. So this is going to give me, we solve that, we get x larger or equal to 4. So the domain is going to be everything, every number, as long as it is bigger or equal to 4. All x's such that x bigger or equal to 4. This is the domain. This will be the allowable value for this function. So 4 acceptable. 4.1 acceptable because give me 4.1 minus 4, which is a positive number. So what's acceptable? Everything that makes the term under the square root positive. Now, effect on the graph, how the graph of this function basically would look like. The effect on the graph is as follows. When we'll pick up a calculator and we graph it, you're going to see the graph looks like this. This is 4. And the graph would look like that. There will be no output here. There will be no output because if I take anything less than 4, even if I take 3, anything less than 4, so for example, sorry, my apology. Sorry about that. So this is the graph. My 4 is right here. The graph is going to look like that. Anything, any input less than 4, even if it's 3.9, will not yield an output. There is no output for it. Everything bigger than 4 will work all right. So that's how it will affect the graph. No output for x less than 4. So let's do 2 more problems along those lines because I know that this is usually hard for the student, but that's okay. So let's take the following and I will let you figure it out. Nothing difficult. So suppose I take f of x to be equal, the square root of the same type of problem, 2x plus 3. A little bit harder, but the same thing. What's the domain of this function? What are the x's that I will allow in here? Actually, I want to make it easier even. So I'm going to make it easier, x plus 3. Which are the x's that I will allow? Solve it a little bit. What do you want? For this to make sense, for the output to yield a number, what should be the restriction? What's causing me problem?
The answer, do you just want me to say the answer?
No, how you got to it?
I did the x plus 3 should be greater than or equal to 0.
That's what we want. X plus 3. Okay, so you have to find the x's that makes the term under the square root positive, not the square root, under it. So it's going to give me x should be larger or equal to -3. So in this particular problem, -3 will do it, because -3 plus 3, it's a 0. -1 will do it. But however, if I take -4, something less than -3, like -4 plus 3, that's yield a negative number. So the domain is going to be everything, all x's. That's true. I'll write the domain in red. The domain is going to be all values of x, such that x larger or equal to -3. So the term under the square root will have to be a positive number. Okay. All right, so I stop right there. Next Thursday is your first exam. So exam 1 is next Thursday. Okay. You will have a review. I will put a review out, so you will have a review hopefully by tomorrow. So review will be on Brightspace by tomorrow. Okay, so I don't need to write this. I will have a review. It will be on Brightspace. Domain will be on your exam, so please do the practice problem. I will not give you a Moodle homework for next Thursday, because actually I want you to go through the review, do it, and make sure you do the practice problem about the domain. The domain always gives the student difficulties. I am aware of that. Let's see if we will do better this semester. Okay, so for Tuesday, make all the problems about domain that I will assign. Go over the review, and I will answer all your questions you have about the review and about the quiz that one of your classmates asked me about. And remember, Moodle homework is due this evening. I know that quite a few of you haven't done it yet. Don't wait till 11 o'clock to do it. All right. Any questions?
So Tuesday is going to